see that as a full screen?
Yeah, we can see the screen.
Okay.
Yeah.
Okay. Hi, my name is Arlena Collins, and this is my capstone project, Secure Cloud-Based File Storage Systems, specifically built using AWS. Thank you for being here. In this project, I focus on cloud security, specifically how to protect data stored in cloud environments like AWS. As more companies move their data to the cloud, security becomes a major concern. Misconfigurations and weak access controls can lead to serious data breaches. The goal of my project is to explore how layered security practices like monitoring activity logs, controlling user access, and securing storage can help reduce risks. This project highlights not only the importance of cloud security, but also practical ways to strengthen it using tools that are widely used in industries today. This project tackles one of the biggest cloud risks, misconfigured S3 buckets. I played with AWS a few different times. I built a secure storage system using AWS S3, IAM, and KMS to lock down access, encrypt data, and prevent exposure. Cloud breaches often happen because people misunderstand what they're responsible for. By working hands-on with AWS and following frameworks like Zero Trust and Cloud Controls Matrix, I gained real-world skills in secure cloud design and identity management. Research shows that cloud misconfigurations, especially open S3 buckets and weak IAM, are a major cause of data exposure. The Cloud Security Alliance highlights misconfigurations and identity issues as top threats, and their cloud controls matrix guides proper encryption and access control. Zero Trust model reinforces the idea of never trust, always verify, which aligns with my project's focus on strong authentication and authorization. Frameworks like NIST SP 853 and the CCM provide the standards for secure cloud design. All of this research points to the same message. Secure cloud storage requires preventing misconfigurations, controlling access, and using encryption, which is exactly what my project delivers. The whole approach is based on secure by design principles using AWS tools like S3 for storage, IAM for access control, and KMS for encryption. I'm also following zero trust and least privilege access, so nothing is trusted by default. In the early sprints, I focused on basic block public access, enforcing encryption, and setting up IAM roles correctly. As the project moved forward, I'm adding more advanced controls like CloudTrail logging, bucket policies, and automated configuration checks. I've also used Agile Scrum, which helped me improve the system step by step and catch issues early. On this slide, you can see a visual diagram of the cloud security model used in my project. Starting from the top, users interact with the cloud system through secure access points. This is where identity and access management, or IAM, plays an important role by controlling who can access resources and what actions they're allowed to perform. Moving to the center, we have monitoring and logging services like CloudTrail. These tools track user activity and record events, which helps detect any unusual and unauthorized behavior. At the bottom, the diagram shows cloud storage such as S3 buckets. This is where sensitive data is stored, and it must be secured using proper configuration, encryption, and restricted access. Overall, this diagram represents a layered security approach. Each layer works together to protect data, reduce risks, and improve visibility across the cloud environment. During the sprints, I started collecting the security data needed to understand how the system is actually being used. I pulled CloudTrail logs to see all user and API activity. Since my project focuses heavily on monitoring and preventing misconfigurations, I also reviewed S3 access logs to confirm that encryption and block public access were working correctly. Finally, I checked IAM role usage to make sure permissions stayed aligned with least privilege. Collecting this data gives me a clear baseline so I can analyze patterns and catch any issues early on. So for the data analyst part, I basically took all the logs I collected, CloudTrail, S3 access logs, and IAM activity, and started looking at how the system was actually behaving. Since my project uses a layered security model, I wanted to make sure all those layers were working together the way they were supposed to. I checked CloudTrail first to see if there were any weird API calls or login attempts. Then I compared the S3 access logs with the bucket policies to make sure encryption and block public access were really being enforced. Overall, this helped me confirm that zero trust controls were doing their job. From the analysis, a few things stood out. First, the S3 logs matched the bucket policies, so encryption and block public access were consistently applied. IAM roles were also looked good. Permissions stayed aligned with least privilege, which is one of the main goals of the project, and I didn't see any unexpected API activity, which was a good sign. During doing this early analysis helped me spot patterns to make sure there wasn't any misconfigurations hiding in the background. In the findings, I analyzed logs from AWS CloudTrail, S3, and IAM. The results showed that the system is secure and functioning as expected. S3 block public access successfully prevented unauthorized exposure, which is a common cloud risk. IAM roles enforced least privilege access, meaning users only access what they needed. All the data that was encrypted using AWS KMS, adding another layer of protection. Finally, CloudTrail logs provided visibility into system activity, allowing monitoring and auditing. Overall, no major security issues were found. In conclusion, this project demonstrates that strong cloud security can be achieved by combining best practices and proper configuration. Using layered security, encryption, access control, and monitoring greatly reduces those risks. The result shows that even at an entry level, implementing these strategies can effectively protect data and systems. This project highlights the importance of building security into cloud environments from the start and maintaining it through continuous monitoring. Looking ahead, there are several ways this project could have been expanded. I would have liked to implement automated compliance checks using AWS config, as well as integrate real-time threat detection with services like GuardDuty. Expanding the system to support multi-region disaster recovery would improve resilience. I would also enhance the learning and incident response capabilities, along with building a more user-friendly dashboard for monitoring. The improvements would make a system more scalable and production-ready. For my capstone project, I kicked things off with a fast-paced demo showing exactly how a secure cloud storage system works on Amazon Web Services. In this demo, I'll walk through the core security tools and show how they lock down data from every angle. I upload a file so you can see encryption kick in automatically and watch public access get blocked in real time. Then I'll highlight how IAM roles enforce least privilege access and wrap up by reviewing CloudTrail logs to show you how every action is tracked for security and compliance. This demo brings the entire system to life and shows how the AWS system works together to protect data end to end. So this is my demo. I'd like to show you, it has a voiceover, so I'm gonna let it play. Hopefully you guys can hear it. Just let me know if you guys cannot. Sorry, my bad. Okay. All right. And then overall, this demo shows how multiple layers of security, access control, encryption, and monitoring work together to protect cloud data. I chose, as you saw, the system successfully enforces configurations, limit access through IAM, and provides visibility through logging tools. These controls align with the best practices like zero trust, demonstrate how even entry level can improve cloud security. I chose this topic because cloud misconfigurations and data exposure are common security concerns, and I aim to illustrate practical security measures simply by emphasizing the importance of layered security. Though I face some time constraints, I would love to add features like automated alerting, AWS CloudWatch, and multi-factor authentication. If I had more time, I'd improve the demo with an interactive user interface and automatic security checks. And then Al-Harkin and Al-Islam's research show the most cloud breaches don't come from sophisticated attacks. They come from simple misconfigurations, things like open S3 buckets and overly broad IAM permissions. To guide the solution, I aligned my design with the Cloud Security Alliance Cloud Controls Matrix, which gives us best practices around identity management, encryption, and configuration verification. These aren't arbitrary choices, they're industry recognized standards that organizations actually use. And finally, the zero trust architecture reinforces the core principle running through my entire design, never trust, always verify approach. The philosophy shapes how I have approached the authentication and authorization at the layer of the system. Basically, nothing gets access just because it's inside the network. And that wraps up the main part of the presentation. Thank you for following along.
Oh,
Let's see, how do I get out of here? Hold on 1 second. Sharing, okay.
yeah. Thanks, Arlena, for your presentation. It's good, and it shows how can we secure the cloud services. And I just have one little question. That's it. What are the encryption tools that I've used in AWS for the S3 bucket? Mm, it says the S3 bucket is encrypted. So I just want to know how did you encrypt the S3 bucket?
Um, so I was still fairly new at using the AWS. Um, so I'm still in that learning process at the same time. So I still have a lot of trial and error when it comes down to it. But I chose this topic considering that I was going to get into, like more of a like healthcare management compliance.
Yeah, okay.
So I honestly have I'm
Yeah, yeah,
trying to, yeah, I
yeah,
don't I
yeah.
don't
I
know
get it.
like the specific answer, because I did with all these courses, we've hopped from so many different things that
Oh,
I chose this as a to try to work more on to move into more later, if that makes sense.
yeah, yeah. I get it. You want to have more hands-on on the cloud. I get it. Yeah, that's all. That's a well presentation from everyone. Those are all very good topics, uh, which can help us in the real scenarios. It's all good. Thanks everyone for the participation, and I look forward. You have a great career. Yeah, thank you all. If anyone have any questions, you can bring it up. Yep. Thanks. Think no one has a question. That's good. Thank you all. Hope you have a great weekend. Thanks everyone. We can wrap up the session.